self-nominated for an award.
Nice.
Apparently, I was like, I mean, right, that happens at Mod all the time. But
Yeah.
apparently, they
Yeah.
told Mary,
That's pretty much all it is.
yeah, but at Mika, the lady's like, oh, we've never, because usually they have someone, like, I would nominate you and I get up and give a spiel. I'm like, oh, very sweet, you won an award. And they were like, oh, it's kind of awkward since you self-nominated. And I'm like, oh, I feel like it should be awkward, right?
Is that a national conference?
No, Minnesota. But yeah, so we have, usually it's, yeah, like Mary Nicole are going, and then Kendra, I guess. And then Tina and I are going just for award purpose.
Fun.
Yeah. Canada. Yeah.
She, have you submitted your abstract for what tech? No.
We well, did you so for a web tech, it's Water Education Foundation technical conference. It's in New Orleans.
Oh.
And we were to submit our partners in Grand and Cap region.
Oh, yeah.
It was a 50-page document on how to submit the abstract. All this one, like guys, and of course that was what I volunteered to do. So you just submit like
It's not worth that.
it's no. And then if you're accepted, you have to write a technical paper. That's crazy. Krista, she'll give me the sign, right?
She's planning on starting at 7.
Okay. Okay. Just a few more minutes, everyone. As tall as you guys. Okay. All right. I got the thumbs up, so we will get started. Thank you, everyone, for being here. My name is Paige Alberg, and I'm part of the Environmental Quality Committee. And this is our first speaker series of 2026. So we host 4 speaker series every year. They are the 4th Monday of the month. So upcoming, we have next month the City of Roseville joining us to talk about their Green to Go ordinance. In March, we have someone from the MPCA coming to talk about PFAS in Minnesota. And in April, we have a presentation from Ramsey County about their food scraps pickup program, which I'm really excited about. Tonight, we are lucky to have 2 presenters from the 2 watershed districts that cover Shoreview. We have Lindsay Flatten from the Ramsey Washington Metro Watershed District. She joined them in 2017 as a water quality intern and then transitioned to her current role as the water monitoring technician. Her degrees include a BS in environmental science and a PSM in conservation biology from the University of Wisconsin in Stout. She assists the water quality program projects, including routine monitoring, maintenance of district infrastructure, and stormwater management. She also assists the education department by preparing and presenting lessons about water quality to students in the classroom as well as out on the lakes. And then we also have Matt Koshin, who is here for the 2nd year in a row. Thank you, Matt. And he is the Lake and Stream Program Manager with the Rice Creek Watershed District. He directs the district's water monitoring program and manages water quality improvement projects. Matt enjoys using monitoring data to diagnose lake problems and then develop projects to address those problems. Matt has a master's degree in conservation biology from the University of Minnesota. So I will turn it over to Matt and Lindsay, and then if you could save your questions till the end, probably, and then we'll pass around a microphone and answer those. All right, thank you.
Okay, thank you, Paige. Yeah, as Paige mentioned, I was here last year, I think, talking about chloride. Now I'm back again, and I'm wondering how many more times I'll be invited back. I think it's until I get it right. That's the answer. I'll keep coming back until I get it right. So I'm here to talk about lakes in Shoreview along with Lindsay. We're going to be going through some slides here. We're going to be taking some turns, going back and forth a little bit to talk about lake issues in Shoreview. So here's our presentation outline. We're going to talk a little bit about who we are and what we do. We'll talk just with some watershed basics to start out, so you kind of know what a watershed is, what a watershed district is. We'll talk generally about what we mean by water quality. I heard lots of other topics that are coming up that are related to water quality. When we say it in a presentation, and oftentimes at a watershed district, that has a specific connotation, so I'll talk a little bit about that. Then we'll get into some of that monitoring data that we have for lakes in Shoreview and talk about what their current health is and what we're seeing there. And I didn't put on here, but we'll finish up with what you can do, what residents can do, what cities can do, what local partners can do to help improve water quality in our lakes. So first off, some real basics, what a watershed is. I mean, we use this term all the time, but very simply, a watershed is an area of land that funnels water down to a specific point, right? So it's easier to think of what a watershed is when you're in a mountainous area and you can kind of tell where the boundaries of it are. It's a little bit harder to visualize it in Minnesota where everything is so flat. But we do know where those watershed boundaries are. Paige mentioned that there's 2 watershed districts that split the city of Shoreview, and I'll be talking more about that. But you can think about watersheds as kind of being nesting too. They're not any specific size. They can be very small, like as big as your backyard, but funnels water down to a certain point, up to something very large. So you can kind of think of them like a nesting doll in that sense. So just a couple of examples. Turtle Lake is in Shoreview. Here's this kind of orange line outlining the area around Turtle Lake that is the Turtle Lake watershed, very small area. That is the Turtle Lake watershed. You could zoom all the way out and think about the entire Mississippi River watershed. Both of those are watersheds, so again, the concept is scalable up and down that way. Okay, yeah, so Paige mentioned it again, but the city of Shoreview is split by these 2 watershed districts, the Rice Creek Watershed District, whom I represent, and Lindsay represents Ramsey, Washington Metro Watershed District. So the yellow line there indicates the Shoreview city boundary. See a bunch of lakes inside the city of Shoreview, and then that purple line kind of bisecting the city is the watershed boundary. So everything kind of on the west side and on the north side of that line drains up towards Rice Creek, which eventually moves down towards Long Lake, and then eventually the Mississippi River. Everything on the east side and the south side of that line drains down toward the Mississippi River, toward the city of St. Paul, kind of, right? Yep, okay. So that's why we're both here talking tonight, because the city is split by these 2 watersheds and 2 watershed districts. So that's a watershed. What is a watershed district? I represent the Rice Creek Watershed District. Here's a map of our entire area. It's a large area, 186 square miles. We cover parts of 28 cities, roughly 55 lakes. If I were to give you a quick tour, I mean, here's kind of the city of Shoreview right here. You can see that. Again, split by our watershed boundary. But we also include parts of Roseville, New Brighton, Mounds View, most of Lino Lakes, Columbus, Forest Lake, all the way around to White Bear Lake. And all of the water in this area drains out through Rice Creek into the Mississippi River, just upstream of the city of Minneapolis. Our watershed district has a staff of about 18 people. We've been around since 1972, and we're governed by a 5-member board. Those board members are appointed by county commissioners. So our board kind of sets budgets, priorities, things like that we work on at a watershed. So that's Rice Creek. Lindsay will talk a little bit about Ramsey, Washington.
Thank you, Matt. So our watershed includes 12 cities within our district boundaries, much smaller than Rice Creek, 65 square miles. And like Matt said, that ultimately drains into the Mississippi River. We've got 20 lakes, 5 streams, and over 1,000 wetlands in Ramsey, Washington Metro. We were established in 1975 under what is now called the Minnesota Watershed Act as a special unit of government. So we plan, we have regulatory needs, and we have taxing authority, and we coordinate between cities, counties, and state agencies at our watershed district. And just like Rice Creek, we're governed by a 5-member board of managers, and they meet every month. And right now we're at 16 full-time employees plus several seasonal interns. So our map, not as clear, but we are over here in Shoreview. So we're kind of looking at Roseville, Vadnais Heights, down to Maplewood, and we are almost in Cottage Grove down here with some of our stream sites that enter the Mississippi River, and that includes Pig's Eye Lake. So as we look at Minnesota as a whole, we can see that watersheds are sort of inconsistent and kind of spread across the state, with a lot of watersheds in the metro area. We're well represented. In addition to that, Red River Basin is well represented by watershed districts, but again, it's inconsistent, and there's a lot of the state that does not have watershed districts, and they can come about with a citizen petition if the residents feel strongly about their water quality.
Yeah, so as Lindsay mentioned, watershed districts, not ubiquitous across the state. They're kind of clustered in different areas. You can imagine with that geographic spread then that the issues that these watershed districts work on are varied, right? Priorities vary from watershed district to watershed district. For example, some might put a whole lot of resources and effort into aquatic invasive species issues. Other watershed districts put a lot more effort into drainage and public ditch issues. Wetland management is another big one. So there's all these different priorities. But even here, just in the metro area, big ones are preventing flooding, invasive species issues. Most watershed districts, including Rice Creek and Ramsey, Washington, regulate land development and redevelopment for like impervious surface, parking lots, roads, that sort of thing. Wetland protection. And then what we are here to talk about tonight is protecting and improving water quality. So we have monitoring programs to look at water quality and protecting and improving our streams and lakes and wetlands. So that's what we're going to be talking about. So again, now when I say the term water quality, that can mean a lot of different things to a lot of different people. Generally speaking, this is what we're talking about. We're talking about water quality issues in lakes and streams, often focused around algae blooms. So nutrient loading and algae blooms. So I'll give you kind of the water quality basics then. Again, this is the way that when we say the term water quality, this is what we mean. So we focus a lot on nutrients like phosphorus and nitrogen. Those are both elements on the periodic table. And these nutrients are required for algae to grow. So if you take clear water, you add phosphorus and to some extent nitrogen, you're going to get more algae growing. For those folks that recreate on lakes in the summer, you know, if you have these really nasty algae blooms, that can come with a whole host of problems. And this is what we monitor, and this is what we're concerned about. And you can think of both phosphorus and algae kind of on a sliding scale. You know, it's not A or B. It's always a sliding scale and you could think of maybe the left side of this sliding scale as being like the boundary waters in northern Minnesota, whereas on the far right might be southern Minnesota, more agricultural lakes. So there's lots of other water quality issues like we mentioned. Paige mentioned that there's going to be a speaker at this series, I think later this month or next month, talking about PFAS. So that's a whole nother water quality issue. You know, there's mercury in fish tissue, there's pesticides, herbicides, coal tar sealants for driveways, heavy metals and arsenic. All of these are real water quality issues too. But generally, these are more the purview of state agencies like the Department of Health, the Pollution Control Agency, those types of groups. It's not to say that a watershed district wouldn't get involved in these issues, and in fact, we've been pulled into a lot of discussions regarding PFAS and fish tissue and that type of thing, but we play more of a supporting role with those water quality issues. Again, we're focused on nutrients, algae growth, and all of the issues that come along with algae growth. So where does this phosphorus come from? If we're thinking about this calculus here, phosphorus is a problem, nitrogen is a problem, where do these nutrients come from? They really come from a variety of sources across the landscape. Agriculture can contribute a lot of nutrients from manure and fertilizers. Runoff from streets and roads can create a whole lot. In some cases, direct discharge from factories or other places like that. Erosion in streams can be a big source of it too, because soil often contains a lot of phosphorus in it. So then when that gets eroded and ends up down in a stream and down in a lake, that carries phosphorus with it. So there's a whole lot of sources in the environment where phosphorus can end up in a stream and then down into a lake. In this area, in the Twin Cities area especially, or in all urban areas really, a big part of phosphorus loading can come from stormwater. So water that runs off of street and roadways carries a lot of phosphorus with it. Whether it's in particulate matter, like in soils, dirt, stuff like that, can be found in chemicals and trash. All of the leaves and grass clippings and things like that can be really high in phosphorus. That can end up in a storm sewer and then washed into a lake. All of those things, and then these storm sewers act as like conveyances that carry phosphorus right down into the lake. I know Lindsay's going to talk a little bit more about that later. So that's why watershed districts, we have monitoring programs to look for these things. There's all these different sources of phosphorus in the environment. There's lots of different places that we go to look for to try and figure out where phosphorus is coming from, getting into our lakes and causing these algae blooms. So we're looking in stormwater systems, we're looking in lakes, we're looking in streams, we're looking at plants sometimes. Erosion in streams can be a big source of phosphorus. All of those are places that we look. Now tonight we're really focused on lakes, so that's what we're going to be talking about mostly, but watershed districts do play that role of looking for that phosphorus and nutrient loading in all of those different sources. All right, back to Lindsay.
All right, so thanks, Paige, for that great introduction. I'll just kind of touch on my role at the Watershed District. So like Paige said, I'm a water monitoring technician, and she had mentioned UW Stout. I have a professional science master's degree in conservation biology. So I started at the district in 2017 as I was wrapping up my master's degree. So I assist our monitoring and research manager, Eric Cordy, who I believe presented at this in the past. And I have three main focuses at my role at Ramsey, Washington. So big part of that is water sampling, and I use ISCO automated remote samplers to capture storm events. And those are basically little R2-D2 robots with sample bottles in them, and I run beverage line into the creeks so I can pull water out when it's raining. I take routine manual grab samples bi-weekly year-round at some of our sites, so that keeps me busy. I'm taking flow measurements in the creek channels every 6 weeks with my coworker Kyle. And then those, I'm all out on the lakes, streams, ponds, and BMPs throughout the Watershed District. Another big portion of my role is infrastructure maintenance. And I attend a confined space entry training every year so I can go into the storm sewers like a tunnel rat and inspect our underground systems. So I assist some of the NASCO tunnel inspections of our storm sewer pipes, looking for imperfections, cracks, spalling in the concrete. Again, looking at underground BMPs. And then we're cleaning the lake and stream outlets after rain events, and we have 110 of those sites we're checking every year to make sure water's moving. And then my educational role, I am both in the classroom and taking students out to the lakes teaching. So I'm actually pulling up water samples with the students, and I'm testing those for chemistry, clarity, species richness with anywhere from elementary school up to 12th graders. So now I'll kind of highlight the lakes and ponds that Ramsey, Washington monitors. So we partner with Ramsey County Public Works, and Ramsey County Public Works samples the lakes in Ramsey County. So we help out the conservation district, and we sample the lakes in Washington County. And those lakes are sampled bi-weekly, June through September, and those include Carver Lake, Tanner's Lake, Battle Creek Lake, and then we've got some smaller systems like Casey Lake, Lake Emily, Markham Pond, Jarvis Mill Pond, Coleman Basin, and Wakefield Pond. That's the big full list. So I'm going out there with what Eric has in this picture, that's a multi-parameter sonde, and that's got like 100 meters of cable on a spool. And that sonde I'm using to capture at depth every 1 meter. So Eric here, he's gonna save a data point every 1 meter, and that's including suspended solids, conductivity, temperature, pH, dissolved oxygen, and like I said, every 1 meter. So if we're the lucky ones and we have to go out on Lake Phelan where it's 92 feet deep and I'm saving a point every meter, but I like that lake. So we calibrate that multi-parameter sonde before departing the office for a sample event. So those samples are taken at the surface of the lake, at the bottom of the lake, and sometimes if it's thermally stratified, where you have warm water on top, cold water on the bottom, you can actually see that line. That's called the thermocline. So I'm taking a water sample above and below that temperature stratification gradient. And that's usually on the big lakes, so Carver, Tanners, Battle Creek. And we send those off to the lab for chloride, phosphorus, nitrogen, chlorophyll A. Oops. And so we don't run those in-house. We ship those off to a laboratory in Burnsville. And the last part of the water quality monitoring program, second part, this is our stream monitoring program. And this picture is a low-flowing fish creek. In a rain event, this will fill all the way up. This is draining Carver Lake in Woodbury. So we partner with the Metropolitan Council for the Watershed Outlet Monitoring Program, and that's on Battle Creek. We're taking those samples bi-weekly, so every other week, year-round, on the same day. I might delay if there's like Arctic air or a blizzard or heat wave, severe thunderstorm, but otherwise we're going out every other Tuesday to keep that sampling consistent. And like I said, Battle Creek, we partner with Metropolitan Council. We monitor Fish Creek, this picture leaving Carver Lake. Oh, Jarvis Creek, that one is by our office. Coleman Creek forms the headwaters for the Phelan chain of lakes. And it's not a creek, but it drains 90% of our watershed district, and that's the Beltline Interceptor Storm Sewer that was constructed in the 1930s. And now has been converted to a storm sewer system, and that drains Lake Phelan. If you've ever recreated on that lake, it flows for 7 miles down towards the Mississippi underground. And so just like our other lake monitoring, we're using a multi-parameter sonde, and again, it's the same gamut, the solids, conductivity, so how many ions are dissolved in that sample, temperature, pH, dissolved oxygen, and so I'm calibrating that sonde before every sample event at the office. And our stream samples are analyzed for chloride, phosphorus, nitrogen, E. coli, suspended solids, and then volatile suspended solids, especially for Coleman Creek forming the headwaters to the chain of lakes. We really want to know what's entering those. And the last part of the water quality monitoring program is the best management practices, or BMPs. So our watershed's very urbanized, and we're looking always at retrofitting. How can we clean or treat or remove phosphorus from water entering a lake? Well, we don't really have the land to do that, so we oftentimes will put those underground. So this is looking actually not into a BMP, but the Beltline Interceptor storm tunnel, but I figured it was a good representation. Got your excavation entry and some equipment mounted to the side there. So our BMPs, we have those surface best management practices. I don't know if you've ever shopped at the Costco in Maplewood. We have a little site on the corner of Beam Avenue, and it's called Barhenge. It's a little stone feature in a iron enhanced sand filter. So that iron actually binds with phosphorus and pulls that out of the stormwater entering that site. We've got a test weir also right by that system. So we've been kind of playing around with biochar, CC17, which I think is actually a chicken feed, spent lime, and seeing how effective some test materials are at removing phosphorus. We're also trying crushed granite. We have a filter near Wakefield Lake, if you've ever been over that way. We have an alum treatment facility that we had constructed in the 90s on the headwaters of Tanner's Lake. So that's an above ground BMP. We're injecting aluminum sulfate into the stormwater during those high flow events. We actually divert the headwaters into our system. So that's super cool. I could do a whole talk just on the alum treatment facility. We have a new Willow Pond CMAC filter. So again, that's that spent lime, which is a waste byproduct of drinking water production. I think they use it as a filter cake to kind of remove excess unwanted material from the drinking water. So it's a free resource and good at binding with that phosphorus. We've got lots of rain gardens around. And our big underground BMP is that Frost Canard spent lime chamber. That, again, spent lime, free material, just pick it up from the drinking water treatment facility. And so while I'm out sampling these systems, I'm taking samples from the inlet, what's coming in, and I'm taking samples at the outlet. And so we've designed a lot of these systems with that in mind, and we've got some ports going into these. It's super handy. So I'm out there from April to November after each rainfall, quantifying what's going in and out of these BMPs. And just like our other sites, we're looking for road salt or chloride, phosphorus, nitrogen, iron, especially with the iron enhanced sand filter, suspended solids, and I'm again using my multi-parameter sonde, looking at suspended solids, conductivity, how conductive is that water, how many ions are in there, how much salt's in there, temperature, pH, dissolved oxygen, and I'm calibrating that before departing the office.
Okay, thanks Lindsay for that rundown. So back to kind of like, now we're going to get into some of the results of our monitoring programs when it comes to lakes. So I showed you this slide before, but now I'm going to highlight these 3 items that are circled right here. Phosphorus, which again is like algae food. Chlorophyll, which is a direct measure of the amount of algae in a lake. And then this little tool right here. Not very complex. This is just a white metal disc on a rope called a Secchi disc that can be lowered down into the lake. And it gives us some idea of water clarity year after year. So the depth at which you lower this thing down into the lake, the depth at which you can't see it anymore is the Secchi depth. Very cheap tool, but it's really nice because it can be standardized, used across the state, used across the country, used worldwide actually. So these are the things that we can monitor in lakes and then report on them. I'm not going to show you too many graphs. Your eyes will glaze over. Some of you might start to fall asleep, but I'll show you a couple at least, just to give you a sense of some of the data that we get from these monitoring programs. So this is Turtle Lake. A lot of people are familiar with Turtle Lake. We've got monitoring data going all the way back to 1980. So there's a really nice record of data on Turtle Lake from 1980 up through 2025. There are 2 bars here. The blue bars are total phosphorus and the green bars are chlorophyll A. Maybe you're squinting to see those bars because they're so small. That's good news. Turtle Lake has very low amounts of phosphorus and chlorophyll A. Not a lot of nutrients, not a lot of algae. It's kind of silly actually that I would have this y-axis going all the way up to 160 when Turtle Lake needs such small amount. We keep those standardized because unfortunately some lakes need that space, right? Kind of the take-home message here for Turtle Lake though is not a lot of change over time. Really nice water clarity doesn't really change over time. Here's Secchi disc. Now this is kind of flipped. Again, we would like to see longer bars here. So like this bar stretching down to 4 meters means that we're lowering the Secchi disc 4 meters down into the lake before we can see it again. So these really long bars indicate good water clarity. One thing I didn't mention here, I'm going to go back and mention this, then I'll save for the other one too. There's these two horizontal bars going across. These are state standards. State of Minnesota has set standards for many of the things that we monitor, including total phosphorus and chlorophyll A. So for the lakes in this region, deep lakes or shallow lakes in this region of the state, you shouldn't see more total phosphorus than this blue line right here, and you shouldn't see more chlorophyll A than this green line right here. Again, that's not a problem on Turtle Lake. Turtle Lake really has excellent water clarity. Now it's the opposite here. We would want to see these bars be longer or pass this state standard, because a longer line means you're lowering it down to the lake again before you can't see it. So better water clarity. So kind of a quick summary here now of Turtle Lake. Again, I mentioned it has a really small watershed, and we can think of that as a ratio, 0.8 to 1. That means there's only about 0.8 acres of land for every acre of lake. That's really unusual to find a lake with this small of watershed, and that very likely contributes to the good water quality in Turtle Lake. Generally, lakes with larger watersheds, that's more land, draining more storm water, agricultural areas, things like that, that all bring phosphorus to a lake. Small watershed, really small delivery of nutrients. If we were to use grades, and we can, Metropolitan Council assigns grades for phosphorus, algae, and clarity. Pretty much every year, Turtle Lake is going to get an A or a B in any of those categories. So the summary for Turtle Lake is that there's really excellent water quality. It's really consistent, doesn't change a whole lot from year to year, and it's meeting state standards. There's not a whole lot of interesting things for us to say about Turtle Lake because not much is changing, and consistent from year to year, really high quality. Island Lake, a little bit more dynamic. So this is the other big lake that is in Shoreview and in the Rice Creek Watershed District, right? Turtle Lake and Island Lake. Lindsay's going to talk about all of the other lakes that get monitored. So Island Lake, again, really long data record going back to 1985, and you can see for many, many years, we were up above this state standard line right here. What that meant was that Island Lake was not meeting state standards. Water quality was typically poor in Island Lake. There were a number of projects that were done, we'll talk a little bit more about those, in the mid-2000s that helped to bring those phosphorus numbers down. And so just a few years ago, we celebrated a win because Island Lake, for many years, wasn't meeting state standards, and then it began to meet state standards. It was actually removed from the impaired waters list. We could spend a whole presentation talking about the impaired waters list, but this was good news. What this was signaling was that there was some improvement happening in Island Lake. Now you'll notice in the lower right-hand corner there, I'm only going up through 2019. Why is that? Well, if I skip ahead to 2025, the story gets a little bit muddled here again. We were celebrating some nice improvements in Island Lake, but there have been some steps backward in recent years, unfortunately. Now, I think a big part of this, I'll cut down to just this note right here. Everybody's going to wonder why water quality might be getting worse in Island Lake. I think very likely the heavy rains that we had in 2024 and 2025 have a big part of that. Many of the lakes in the Rice Creek Watershed District in 24 and 25, we saw worse water quality because we had warmer weather and a lot more rain, and those two things combined mean more nutrients getting delivered to a lake and then more algae blooms being fueled. But the take-home message here for Island Lake still has fair water quality, and when you go back and compare this to what we saw in the 80s and 90s, it's still much improved to what it was. In recent years, it's kind of been oscillating a little bit. And again, I think that the heavy rains that we had in recent years probably have a lot to do with that. All right, Lindsay will talk about Ramsey Washington Lakes.
All right, so before I jump into the Ramsey Washington side of Shoreview, I will just touch on those water quality state standards for the deep lakes and the shallow lakes. So deep lakes must have less than 40 micrograms per liter total phosphorus, less than 14 micrograms per liter chlorophyll A, so that's that pigment in algae. And then chloride, the state chronic or long-term standard is 230 milligrams per liter. Shallow lakes under 15 feet deep, so 15 feet, those need to be under 60 micrograms per liter of total phosphorus, less than 20 micrograms per liter chlorophyll A, that transparency greater than 1 meter. And I don't know if I mentioned for the deep lakes, the transparency state standard is greater than 1.4 meters. So 1.0 for the shallow lake transparency. And again, that chronic state chloride standard is 230 milligrams per liter. So here are our lakes in Ramsey, Washington. We have Wabasso, Snail, Grass, which is technically a wetland, same with Lake Judy, Lake Emily, which is a shallow lake, and Lake Owasso. So we'll jump right into Lake Wabasso, the smaller and deeper lake next to Owasso. So Lake Wabasso is classified as a deep lake. We're at 66 feet. Our 2025 summer average data is 26 micrograms per liter TP, or total phosphorus, and that's a A to B grade. Our Secchi disc transparency is great. The summer average for that summer last year, 2.77 meters, so that's an A grade. Chlorophyll A, or algae, also is very low at 10 micrograms per liter, A grade. Our chloride is looking good. We've incorporated chloride sampling into everything we do, trying to get a feel for where all the salt is settling. So that's at 72 milligrams per liter, a different unit, and that's well below that 230 milligrams per liter chronic state standard. So we've got 42 acres of total lake area with Wabasso, and a lot of that is littoral area, or you can think of it in the edges of the lake where that light penetrates all the way to the bottom, fueling plant growth. So 27.8 acres of littoral area on Wabasso. So Snail Lake, really close by. That's classified as a deep lake as well, and our summer 2025 averages. We're looking at a bigger tributary area, and I should have reduced the numbers to look at that watershed to lake ratio, but you can see we have 190 acres of lake with 961 acres of tributary area. I should have thrown the map up here, kind of outlining that watershed, but that's a lot of stormwater entering Snail Lake, and so we see that reflected in the numbers. So our total phosphorus is a bit higher for this lake at 50 micrograms per liter average last summer, and that would give it a C grade. Our Secchi disc transparency is at 1.7 meters, and that's a C grade as well. But not seeing a lot of chlorophyll, so at 17 micrograms per liter, that's a B grade. But we are seeing more salt, and I definitely think that's a bigger factor with the larger tributary area. Everyone's salting their sidewalks, driveways, MnDOT's out on the roads, so it's all washing in, and you see that with 138 milligrams per liter of chloride in Snail Lake, which there are no grades yet for chloride, so it's definitely an emerging concern. So looking at Grass Lake, I'm saying lake facts, but this is actually just a wetland right near 694, 16 acres in size, and we don't have a lot of monitoring data on this. The islands move, they're floating vegetation mats, so launching a boat in this is very tricky, and we don't monitor this very often, but a lot of total phosphorus, and I guess this has a grade even though it is a wetland, but looking at between 1.5 and 2 meters of Secchi disc clarity, which is F grade. Looking at the chlorophyll A, though, there's only 10 micrograms per liter for this system, and that would be an A. So chloride, though, is looking under 100 milligrams per liter. So with 694 right there, this is kind of a hot spot, and we have monitored this in the winter in the past because the islands then are at least frozen in and don't move on you. So that is Grass Lake. Lake Judy is also a wetland, which is, fun fact, the same size as Grass Lake, 16 acres. Lake Judy has been receiving some attention for these high numbers. And I have the 2010 averages. This is a lake that's routinely monitored by Ramsey County. So Ramsey County kind of takes the lead on Lake Judy. We monitor some BMPs downstream and some of the connecting lakes. So we're looking at 170 micrograms per liter of TP. But again, this was in 2010, and this is just the data that we had internally. F grade for TP Secchi disc at 0.62 meters, that's an F. Chlorophyll A, 64 micrograms per liter, which is a D, and we don't have chloride data on this. But this, yeah, if anyone has any specific questions, I could reach out to Ramsey County. So Lake Emily is classified as a shallow lake. So Lake Emily is 13 acres in size. The tributary area, though, is 244 acres, 15 feet of depth, and Lake Emily drains to Lake Owasso. And so we're looking at 84 micrograms per liter of TP, or total phosphorus, as a D grade. Secchi disc transparency at 0.93 meters, that's also a D. Chlorophyll A, which you'll see there is 90 micrograms per liter, or an F grade, and chloride is staying low at 45 milligrams per liter. And last but not least, Lake Owasso. Looking at the total phosphorus for Lake Owasso last summer was averaging at 36 micrograms per liter. That's a B grade. Secchi disc transparency, 1.6 meters, or a C. Chlorophyll A at 29 micrograms per liter, also a C. And then chloride at 71 milligrams per liter. So we're below that state standard. And if you notice, so we're classifying this as a deep lake that is 375 acres. The tributary area is 2,175 acres. So you can see that kind of reflected on this right side here with these grades. That's a lot of storm drains going into this. And, sure.
So I think the take-home message for the city of Shoreview is kind of laid out in this slide here, and that is that when we think of these phosphorus concentrations and algae concentrations in lakes across the city of Shoreview, Shoreview really runs the gamut. From Turtle Lake, which is a really high-quality lake with really excellent water quality, low phosphorus and algae concentrations every year. It's one of the better water quality lakes in our watershed and really the metro area. But then it runs the gamut all the way up through Island Lake and Judy Lake, and then kind of everything in between. So it runs the whole gamut here. And some of these lakes, you know, Turtle and Wabasso, I think we're kind of in protection mode at this point. You're trying to make sure that development that's happening in those areas is not impacting those lakes. Island Lake and Judy Lake, then, we're really more in what can we do for those lakes? What can we do to improve them? Should I run through a couple more, or do you want to jump in here?
Oh, I can jump in.
Okay.
All right, so that takes us to how can we, as citizens, get involved, and we, as watershed districts, are here to help those individuals and the cities, counties, and even the state sometimes. So we can see here on the left, this shoreline is pretty much non-existent, lots of soil entering the lake, which soil has phosphorus, nitrogen, and I also see a road over here, so it's probably entering some road salt. And if you look on the right side, so this is some of the work we do. I see some bank stabilization, some plantings here, and just kind of running down that shore. So it's kind of a night and day difference, and these are the fun projects we like to work on, these shoreline stabilization projects. So, partnering with us, we, here we go. So, like Matt said, these sewer grates the storm sewers are capturing everything that's on the road. So we're looking at this really complex system. We've got yard runoff. We've got downspouts from the houses carrying rain, water. We've got runoff from roofs, concrete, blacktop, impervious surface. So that water is entering our lakes untreated, unfiltered, and we've kind of been working with some organizations to get some branding on our storm sewers, like no dumping drains right to lake, or putting like a fish icon on there, just trying to help people kind of visualize that. So things like salt, fertilizer, oil, fuel, grass clippings, like Matt had said, dog poop, leaves, trash, all ending up in the lake. So what can we do? And that's where the watersheds come in. And rain gardens are a really great way to slow down that sheet flow in a high rain event or a big storm we get in the summertime. So this is looking at the Milton Street Rain Gardens, which I believe is a MAT project. And yeah, those rain gardens have these native plants. And so those native plants have really long root systems and can actually stabilize soil, hold that flow back, and infiltrate that water slowly into the ground instead of this just sheeting right off, going right into that lake. And so those native plants also offer habitat for critters, nectar, pollen, seeds, physical housing for our bumblebees and other critters like that. And on a bunch of these slides, we've got our websites at the bottom, but it's just a quick Google too if you wanted to see our stewardship grant program or the Rice Creek grants. So again, we're working with these really urbanized watersheds. How can we help Island Lake? And so oftentimes that's like a retrofit where we're looking at an existing property and how can we help? Maybe we're looking at where the flows are going during high rain events. And so strategically placing a rain garden like this, where those native plants, they're going to hold back, they're going to infiltrate that rainwater, offer habitat for native critters. This is what we're looking at, is looking at those retrofit projects. So habitat creation and water quality. Rain gardens, I can't say it enough. So here's a site, as we can see, on a lake, and we're noticing the road is probably funneling the stormwater right into this lake. And we're seeing someone thought, oh, put some Jersey barriers up, maybe that will do it. But again, this isn't looking like a good situation. And so someone thought, hey, let's cut that off. Let's put in a rain garden. Let's funnel flow down. Let's have that infiltrate through the groundwater and refill the lake that way with filtered or more filtered water. And we're providing, again, that habitat for native critters and, stabilizing that soil. So definitely looking a lot different from this picture on the right to that picture on the left. And there's a rain garden in action. So this is what they're supposed to do. This looks like a newly planted one. The plants aren't very large yet, but they'll get a nice boost of growth with this water. So if you see a rain garden looking like this, it's doing its job and it's slowly percolating that water down into the groundwater. And here I see some biolog shoreline stabilization. I see some plantings, and it is looking like they've directed, it's a low-lying area, so native plants, we're holding back that soil, we're stabilizing their shoreline, but they're still able to use this site, and so kind of shaping a native planting around how you use your property. That's a smart way to do it, and that's kind of the technical expertise that we offer at the Watershed District with our designs. So I've just kind of summed up a couple ideas here with how can residents and municipalities get involved. So we've got our stewardship grant program at Ramsey Washington Metro, and I'll dive deeper into these ideas, but we offer technical and financial assistance to protect water resource projects. And so as a citizen, you could get involved with some volunteer water monitoring, and the Minnesota Pollution Control Agency and the Metropolitan Council offer some citizen science programs. Like I said, native plantings, they're providing nectar, pollen, seeds, habitat for wildlife. The deep roots hold soil in place and prevent erosion. And if you're unfamiliar with Leave No Trace, that's 7 principles, emphasizing minimal impact practices outdoors. So we'll kind of just run through our stewardship grant program. So I will just put all these up here. Okay. So people, businesses, churches, schools, associations, and government agencies are all eligible to apply for a grant through the Ramsey Washington Metro Watershed. We support, like I said, projects and efforts that improve water resources or knowledge about water resources. So we partner with Ramsey County, and we offer free site visits and design with the Watershed District. So the funding amounts vary depending on the type of project and location. We've got some priority zones in our watershed. Our new focus areas are the chloride reduction projects, partner grants, and street sweeping equipment purchasing. We have a whole tab on our website on stewardship grant at rwmwd.org. So this photo, we're looking at the newly planted Snail Lake shoreline restoration in Shoreview right here. So hummingbirds, native birds, bumblebees, all sorts of critters are going to benefit from this, and the lake itself holding back that sheet flow. And I also see potential to hold back the geese, because the geese really like to come up when you mow. So this Snail Lake restoration is doing really well. I believe we have 14 shoreline sites on Snail Lake that were restored through our targeted retrofit program. And our contact for that is Ashley Ricci. So I threw her contact info up here, but again, it's a quick Google search online through our website and easy to find. So volunteer water monitoring, I have a ton of info. I'm just gonna throw it up on the screen. But the Met Council has their camp program. Oops, and let's see. So this is actually how I got involved with water monitoring in 2012. And so I was living in Wisconsin. I got involved with the Water Action Volunteers, and we were going out in the summertime, taking temperature and conductivity readings in the stream. And I just like to be outside, and I realized I could do this for a job. And so programs like these can really impact kids, teens, young adults, and kind of help them choose a career path. So there's a ton of info on the slide, but I threw up some contact information. Brian Johnson is the Met Council contact, and then the volunteer monitoring program at MPCA. They have a bunch of phone numbers at the bottom there. So native plantings, I've been talking about them this whole time. Once they're established, they seldom need watering. Native plants produce nectar, pollen, seeds, providing food for wildlife, those deep roots, which you can see in this illustration. I think turf grass is right here. So super deep roots holding back, infiltrating that water deep into the ground. And I just wanted to throw up a seed resource. It's the Minnesota Seed Project that started in the Capital Region Watershed District in 2020, and they offer seed education workshops, so native seed collection, cleaning, germination, propagation. I've attended some of their workshops. They're super helpful. So I just wanted to put up their website. It's that Minnesota Seed Project, and they can help you with pretty much anything you need with native seeds. So Leave No Trace, just wanted to introduce this thought. These are 7 principles to minimize your outdoor impact that can be applied from the local park in Shoreview, but all the way out to the backcountry. So anyone who's using the outdoors, and I will just go through these quickly. This is all online. They have coursework, but step 1, leave no trace, plan ahead and prepare. Travel and camp on durable surfaces. Dispose of waste properly. Leave what you find. Minimize campfire impacts, respect wildlife, and be considerate of others. And again, there's a ton of information online about Leave No Trace, classes, educational materials, and they go through all of their, they work with wildlife biologists on some of these. They're super cool. So there is more info. Yeah. So we are very happy to take anyone's questions at this time, and thanks for listening.
Yeah, we can repeat questions, yeah.
The rain gardens, it looks like they have a big catch area with a grate over that. The water's designed to go down, but at the back of it, there's a cut. So if that, I saw one that was very clogged. So if it's not functioning, the water will go over that cut there and escape. There's no flood hazard, I guess, is what I'm trying to get at. If they're clogged or if there's too much water, there's a
Yeah.
for the water to go.
Yeah, the question was about, several of our photos of rain gardens had these kind of grates or turrets, almost look like, at the entrance of them. And the question was about if they ever get clogged, would there ever be a flooding issue or anything like that? The answer is no, not a flooding issue. The purpose of these things, and they've really grown in popularity in recent years, is to capture leaves and silt and sediment before those things make their way into the rain garden. Because then these can be used for maintenance. The grate you can actually lift up and then shovel those things out and then just carry them away in a pail. So it's like it's a maintenance helper. It's to prolong the.
Clean it up once in a while.
Yeah, yep. And here's another picture of one right here. These are commonly used now. So yes, sediment will collect in those, and leaves and things like that will collect in those. But you can lift up the grate, shovel that out, and it helps actually prolong the lifespan and improves the performance of the rain garden behind it. So it's been a nice addition to a lot of rain gardens in recent years.
One of your early slides, you mentioned coal tar driveways.
Yeah. Yeah.
What is that about?
I won't go back up to it. Yeah, the question was about coal tar sealants. That kind of fell into the realm of things that a watershed district might kind of partner on, but we're not really leading the way necessarily. But coal tar sealant is one of the many like industrial style chemicals that can end up in our wetlands and our stormwater ponds and things like that. I think less so now, and I could have sworn maybe there were some laws recently passed that are banning now certain type. Yeah, it's been phased out.
Used to represent this area, who's passed away recently, championed getting rid of.
Excellent. Yep. So there have been some laws recently to ban that, but for many years that was an issue. So driveway sealers, road sealers, and things like that would have polyaromatic hydrocarbons, PAHs. And those were like volatile organic compounds that would end up in our lakes and our wetlands and things like that. One of the bigger issues with those and so many of these things is we've created hundreds or thousands of stormwater ponds across the metro area and housing developments and things like that. And all of those ponds were really good at capturing pollutants before that water made their way into lakes, including things like PAHs and other compounds. And then when you go back to those ponds 20 or 30 or 50 years later to clean them out and you find all of those compounds, it's actually really expensive to dispose of them. They need to go to specialized landfills and things like that. So that's PAHs. But yeah, again, they're being phased out, so some really good news there. Sir?
You mentioned Turtle Lake has a small watershed. Where does it get its water from? And now I've heard things over the years that whether they're true or not, I don't know, you could probably shed some light on it. Marsden Lake in the Arsenal off Lexington, is that connected
Wish I could find the bigger map here. They're all part of, yeah, so the question was about Turtle Lake and the watershed and where the water comes into Turtle Lake. So Turtle Lake does have a really tiny watershed, and this is the extent of the area of land that drains into Turtle Lake. So any rain that falls in that area drains off into Turtle Lake. That's a really small area. We think there's probably some groundwater inputs occasionally into the lake also. But if you're familiar with Turtle Lake, you also know that water levels can vary quite dramatically over the years. Perhaps not as dramatically as like White Bear Lake, but that's the issue with lakes with a really small watershed. Because they don't get a lot of water being delivered from the tiny watershed, in dry years, water levels can go down quickly, and in wet years, they can come up quickly, and you get a lot of that bounce. White Bear Lake also has a small watershed. Compare that to a lake with a really large watershed, like, Owasso, yeah, probably much more stable water levels in Owasso Lake, but then more nutrients being delivered too. But then those other areas like Marsden, they are nearby. They do not drain through Turtle Lake, though. They're kind of adjacent, I think across the street on the west side. And both of those areas drain to the north, and then eventually, I went all the way back up to our, if I went all the way back up to our map of the Rice Creek watershed, you could see it perhaps. Where was it? There it is. Turtle Lake is here, Marsden Lake and the Arsenal, both of those areas drain to the north and then eventually into Rice Creek, which goes down toward the Mississippi River.
Now, Snail is a lake that I think the level is significantly higher now than it used to be. What changed there? How did that happen?
Well, we saw high water levels after the big flood we had in 2016, 2017. And so that's when that water level on Snail came up. I think somewhere between like 30 and 50 feet on some of those banks, and especially impacted that park right on the south shore there. But now those water levels have gone down a bit. We actually, on the Ramsey, Washington website, have a Snail Lake water level monitor that we publish on there. And so not during the winter time, but growing season, you can actually go back and see exactly where that lake level was. That's kind of cool. But that was installed after that big flood we had in 2016. So my coworker Kyle works a lot with our engineers on that lake level monitoring setup. And so, yeah, if you peek around on our website, or I can give you a business card, and if you wanted to look at some of that Snail Lake data.
Yeah, that spectrum of, water quality in Turtle Lake had very good results there. How would you compare that to, say, like Square Lake out in Washington County? I think that crosses both your watersheds, but do you have any?
Yeah, the question was how Turtle Lake might compare to Square Lake out in Washington County.
Where would Square Lake fall on that?
Where would I don't know. I don't know yeah. Where would Square Lake fall in this continuum? Where did we have that? I'll go down here to that continuum again, and we could find that. I don't know exactly what the phosphorus concentrations in Square Lake are, but I'm guessing it's going to be down in the 10 to 20 range around Turtle. Do you know what the concentrations are?
I don't, but I paddleboard out there and I never see algae, so it's got to be on the good side.
It's on the low end. Yeah, it's going to be down in, I mean, Square Lake actually has trout in it, which is rare for the Twin Cities metro area. So it's going to be down in probably this 10 to 15 microgram per liter range.
And then just a second part to the question. I think Owasso probably 10, 12 years ago had a big winter fish kill in it. Does water quality have any impact on that, or was that what was the?
Yeah, so the question was a Owasso fish kill in the past. And so we are actually going out now in the winter time as the watershed, and we are I'm taking that sonde out with me, and I'm checking on the dissolved oxygen a lot more than we were 10, 15 years ago. But honestly, it's kind of a perfect storm event where you've got a lake with ice cover, you've got a large snowfall, so then you're blocking out all light from going under the ice to the plants. And so that is more like that perfect storm of ice plus snow equals no light, so no oxygen being produced from our aquatic plants. But in terms of water quality, I mean, if the fish are in there long enough to decay, that's a large nutrient source. And oftentimes the fish float after the fish kill, get eaten by eagles, otters, muskrats, or wash up on people's shores. And so ultimately, they'll probably get removed. But yeah, do you have any thoughts on that, Matt?
Winter kill is pretty common across the metro area in shallow lakes. A lot of the lakes in this area have aerators on them. So Island Lake, for example, which is in Rice Creek, there's an aerator that's run there to prevent winter kill. But yeah, like Lindsay said, in more severe winters with early snowfall, thick ice cover, and then the longer into the spring that ice cover persists, the more likelihood that a winter kill is going to happen, just because those fish are not getting any oxygen being replenished into the lake during that time. Generally speaking, lakes that are more productive or have more phosphorus and algae are going to be more prone to winter kill than a lake like Turtle Lake or you mentioned Square Lake. Those lakes are going to be far less likely to have winter kill. It's not impossible, but less likely because there's less decaying organic matter that uses up oxygen. Yep. Sir.
Speaking maybe of Turtle Lake, just as an example, it seemed that the watershed area was pretty small around.
Mm-hmm.
Is that mostly surface topography that's defining that as opposed to, say, groundwater?
Yeah, the maps, the question was about the watershed around Turtle Lake and why it's so small. Is that just surface water, or does that have some groundwater component into it too? These maps that we show, I think we're going the other direction. The maps that we show, the watershed maps for all these different lakes, I'll go down it again, like Turtle Lake here. This is just for surface water. So this area of land right here inside this boundary, that's if rain is falling and then running across the surface of the land, that ends up in Turtle Lake. Groundwater hydrologists can also draw like a groundwater watershed, sort of, you could call it that way, where knowing about which direction groundwater goes, you can kind of define the areas for groundwater too. But they can have some overlap with surface water stuff, but they're different too.
Just to follow up, then, is groundwater also monitored within your districts?
Yeah, is groundwater monitored in our district? I think that would, for the most part, that falls under one of those things that watershed districts partner on, but often we're not leading the way for groundwater monitoring, especially when it comes to like drinking water. People often ask about drinking water and drinking water monitoring. Watershed districts generally don't do drinking water work, but we might do some shallow groundwater monitoring for different reasons. Did you want to add to that? Yeah.
Yeah, so we've installed some groundwater monitoring wells around Grass Lake in particular and Snail Lake. And we're actually measuring the height of the groundwater. And so we were really paying attention to those after that big flood came through. But that's kind of the extent that I've worked with it at the watershed, just keeping an eye on levels and how much storage do we have? Can we move water from one system to the other in the case like Grass Lake? But
Yeah, many people may know that the Twin Cities Army Ammunition Plant is not too far from here and not too far from Turtle Lake. Groundwater monitoring around there for industrial pollutants and arsenic, things like that, is a big deal. That's not really something that watershed districts work on, but we get exposed to some of that information.
Speaking of that, is it Round Lake that's on the southwest corner of 96 and 10? That's under your purview, isn't it, with the Rice Creek watershed?
Yeah, let me go up to it really quick. I think this might be the last question if we're running out of time, right? Yep.
I'm just gonna ask you if that's as polluted as they say it is.
Yeah.
Is it beyond reclamation?
Question is about Round Lake, which is just to the west of Shoreview, and that lake was historically polluted by the Twin Cities Army Ammunition Plant. I think they sent a lot of surface drains actually down towards Turtle Lake. So sediment, or I'm sorry, not Turtle Lake, Round Lake. So sediments in the bottom in Round Lake have showed up, they're showing heavy metals and arsenic and things like that, and yeah, it's a problem. Actually, the Army, working with U.S. Fish and Wildlife right now, is working on a plan to dredge up some of those materials and dispose of them. Huge, many millions of dollars effort, led by the U.S. Army. Yeah, a lot of good questions.
Yeah, good questions. Thank you, everybody. I think Matt and Lindsay will be here for a few minutes after if you want to catch them with questions. But I want to thank you guys for being here and for all the great information. Thanks to all of you for coming out on this really, really cold night. Be sure to join us again next month. It's February 23rd for our next speaker. We'll have a Roseville sustainability specialist here to talk about their green to go takeout container ordinance. So thanks again. Have a good night.
Good.